Okay, today's lesson is going to cover arithmetic sequences, S.5, Spiral 5. Goal is to create an equation or a rule that models the pattern of an arithmetic sequence. Sequences that are arithmetic are types of functions. That's why we use the word rule, because we've learned about function rules, right? Key terms today, just arithmetic sequence is a sequence of numbers such that the difference, we know that difference means subtraction, between consecutive, meaning next to, terms is constant, which we know means stays the same. Something is constant, stays the same. Here's our general form for our general rule for modeling these types of sequences. We've got f of n. N's taking the place of x. It's just a different letter for distinguishing between a sequence and a linear equation. Equals d times n, right, plus a, where d represents difference, which we know is the change between. So this would be like if we're comparing it to y equals mx plus b, we've got our y, or our slope. N would be our input, right, which we call number of term in the sequence. So first term, second term. And then b, which is our y-intercept. Here it's our initial value, right? And then as a side note, this is important to understand that sometimes sequences begin counting from 0 or 1. And that's important to note, because if you start counting at 0, that means the second number in your sequence is considered the first shape, or shape 1, and then the second shape would be, or the third shape would be shape 2. If you're starting counting at 1, that means you have 1, 2, 3, 4. If we start at 0, we've got 0, 1, 2, 3, right? So I'm just going to go ahead and show you what I mean when I say that. So we got shape 0, shape 1, shape 2, shape 3, or we could have shape 1, shape 2, shape 3, shape 4. So this is important to understand where they're starting to count from, and it's always going to be given to you. So let's just assume, for this example, we're starting with shape 0. And this pattern of numbers models an arithmetic sequence, because if you look at the values, right, which values would be our output, and shapes would be our input. If you look at the values, the difference between them, between the numbers, is 3. So if we wanted to predict what the next number would be, or what shape 4 would be, we would just add 3 to 10 and we'd get 13. Well, we could actually use a rule for that, because we know all of these things. We know that the rule for this particular equation, or arithmetic sequence, sorry, is f of n, where a is 1, because that's the first value, our initial value, and our difference is 3. So we can say 3n plus 1. Let's go ahead and get to a couple examples today. Example number 1. It's asking us to write a rule, or another way of thinking about that is to create an equation. And you can see that they're starting to count from 0. 1, 2, 3, and they're calling these shapes, and they're calling these dots, where these are our output, this is our input. So our first step is going to be create a table, and the table is going to be the number, term, and the value of that term. So we've got n, we've got v. this is going to help us figure out the rest of the equation. So in 0, 1, 2, 3, value of 0 was 2, 1 would be 5, 2 would be 3, 6, 8, and 3 would be 1, 2, 4, 11. So we got to figure out what the important information is. We know that A equals, our initial value is 2, right? Now we've got to find the difference. So the difference between the consecutive terms, the difference between 2 and 5 is 3, 5 and 8 is 3, 8 and 11 is 3. So we know the difference equals 3. So we've got enough to create our equation now. We can go ahead and say that f of n equals our difference, which is 3, times our numbered term, plus our initial value, 2. And I forgot to write in the steps as I went. So create a table would be step 1. Step 2 would be find the change. And then step 3 would be create the equation or rule. And step 4 would be to check rule. So if I'm going to check the rule, what I'm going to do is I'm going to take one of the values in terms that we know. So for example, let's take 2. And I'm going to put 2 in to our function and see if it gives us an 8, right? So when I put in 2, we got 3 times 2 plus 2, 3 times 2 is 6, plus 2, 6 plus 2 is 8. So we got 2 gives us an output of 8, 2 gives us an output of 8, the rule holds. Let's go ahead and do example number 2. So here we have our shapes, and here we have our values. And I've been using this as n, right? So we'll say n, it's better. So go create our table. We've got n, we've got v. When n is 0, v is 4. When n is 1, we've got 4 right here, and then we added 4, so we got 8. We got 4 right here, we added 4 right here, and we added 4 right here. So 2 would be 12. And you've probably already figured out the pattern now. 3 would be 16. So we've got A, which is our initial value of 4. We've got D, which is our difference, which we know is 4. So now we have enough to create our equation. F of n equals D, which is, 4 times n plus our initial value of 4, right? Give us initial value of 4. Go ahead and check one of these terms. So I'm going to check 3 this time. So we put in 3, we got f of 3 equals 3, 4 times 3 plus 4. That's 12 plus 4 is 16. 3 has an output of 16. That's correct. 2 more examples. Now these next 2 examples are asking you different questions. So here it's asking us how many dots would, and I'm going to go ahead and make this better wording because it's kind of confusing. Shape 5 have. So we've got shape 1, shape 0, shape 1, shape 2, shape 3, shape 4, shape 5. So how many dots is it asking us to find? Well, if these are our inputs and these are our outputs, this is what do you do when you're given the input? Well, you've got to find the output, right? So step 1, our steps would be to create rule. So if we're creating a rule, we're going to do our numbers, our values. Should be very fast now. 1, 2, 3. You're finding how much are they, changing by. Got our triangle. Add 2. So we've got initial value of 3. Then we added 2 to get 5. Then we added 2 more. So we've now got 7. Then we've got our triangle. We added 2. We added 1 more. So we added to 9. right? So our rule here is f of n equals our difference, if we're adding 2 each time, is 2 times n. Our initial value was 3. And now we're given our input, so we're going to evaluate input to find output. So really just 2 steps, right? So we're going to put in our input. 2 times 5 is 10, plus 3 is 13. So 13 dots would be the number of dots in shape 5. Last example today. I always do this. Maybe one day I'll go through a video without doing it. So we've got our steps down here. And they're very similar, except now the question is saying what term, or we can say, what shape has 1,501 dots. So now we're trying to find our input. So step 1 would be to create rule. So we got our number, we got our value, creating the rule. 0, 1, 2, 3. 0 has 1 dot. With 1 dot, then we added 6. So we have 7 dots from shape 1. We added 6 more, so now we've got 13. And we added 6 more, so now we've got 19. Okay, our difference, right? If we're adding 6 each time, we know it's 6. So we know that our function is f of n equals 6 times plus our initial value of 1. We're trying to find the input. So the next step would be to use output to solve for input. So we're going to take our output, 1,500 dots, and we're going to put it where our f of is 1,501, right? And we're trying to find what n, or what number shape, has this amount of dots. So we're just going to solve. Minus 1, we have 1,500 equals 6n. And now we're just going to divide by 6. Divide by 6. We know that the number term that has this amount of dots is, and I'm going to freehand this one because I didn't have the calculator ready to go, 0, 250. So the shape number 250 will have 1,501 dots. Good luck on your homework.